Good day. My name is Noel D. Martinez and I'm an English teacher at Langkaan National High School, Dasmariñas City, Cavite. Presently, I am taking up my master's degree at Pacific Intercontinental College, and I'm taking up two subjects. One is the curriculum development and supervision, and the other one is educational statistics. And today I'm going to give a summary of the modules that were given to me as part of my final examination, and this is going to be an overview of it. First, I would be giving a summary about sampling, probability, sampling distribution, about hypothesis testing, the pitfalls of hypothesis testing, and I would also be recapping something about confidence interval, about population mean, and also hypothesis testing for independent sample and also for the dependent sample. I will also be giving a summary about the guidelines to take on hypothesis testing, the chi-square goodness of fit, and the chi-square independent test, and the last one is the analysis of variance, or what we call the ANOVA. Now, in the previous modules that I studied, I learned two variables, and these are the following. The first one is a dependent variable, and the second one is the independent variable. Now, the dependent variable is also known as the response variable, right? This is the variable that we are trying to explain, and this is represented by letter Y. On the other hand, independent variable is also known as explanatory variables, or we call this as the factors. So it is represented by letter X. Now, we know that statistics are mathematical characteristics of samples, and part of understanding this statistics is to know something about parameters, and parameters are mathematical characteristics of populations. Statistics are used to estimate parameters. Now, let's assume that there are 2,000 students, and from these 2,000 students, right, they are regarded to be the population. Out from these 2,000 students, 500 will be selected and interviewed, and these 500 students will be regarded as the sample. Now, 74% of these 500 sample are discovered to have a job during the semester, and this percent, 74%, is what we call the statistic. Now, how about the parameter in this? The parameter in here is what we call the percentage of all students in the population who have a job in that semester. Now, briefly, let me tell you something about four types of sampling. First one is what we call the simple random sampling. Second is the systematic random sampling, the stratified random sampling, and the last one is the cluster sampling. Now, what is sampling distribution? This is regarded as the single most important concept in inferential statistics. Now, the distribution of statistic for all possible samples of a given size, or this is represented by letter N. The sampling distribution is a theoretical concept, by the way. Now, every application of inferential statistics involves three different distributions, and what are these three? First is the population, second is the sampling distribution, and the third one is what we call the sample. There are three properties of sampling distribution. Number one is that it is normal in shape. Second, it has a mean equal to the population mean. Third, it has a standard deviation equal to the population standard deviation divided by the square root of n. Now, let me move on summary about probability. In understanding probability, there are two approaches which I will be mentioning. The first one is the frequentist approach. What is this approach? Probability should be assessed in purely objective terms. It means that it's not subjective. The knowledge about probabilities comes from the relative frequency of a large number of trials. Now, this is good model for coin tossing. Now, it is not useful for archaeology, primarily because in archaeology, there are many events that interest us, but these are actually unique. Now, the other approach in understanding probability is what we call the Bayesian approach. This was conceptualized by Bayes' theorem. This was conceptualized by Thomas Bay, and he called this as a Bayes' theorem. He was an 18th century clergyman, and he concerned with integrating prior knowledge into calculation of probability. He found this frequentist approach, the approach I made mention a while ago, as something problematic. And according to him, prior knowledge is equal to bias or subjectivity. Now, let me move on to hypothesis testing. What are the concepts that we are to understand about hypothesis testing? Okay, first one, there are two hypotheses that we are to make. The first one is the null hypothesis. Second is the alternative hypothesis. The procedure, second is the procedure begins with the assumption that the null hypothesis is true. Number three, the goal to determine whether there is enough evidence to infer that the alternative hypothesis is true or the null hypothesis is not likely to be true. Now, there are two possible decisions we can come up into. The first one is that conclude that there is enough evidence to support the alternative hypothesis. If this be the case, you are to reject the null hypothesis. Second decision would be conclude that there is enough evidence to support alternative hypothesis. This would mean to say that you fail to reject the null hypothesis. In understanding hypothesis testing, we are to recall the Pascal's wager. And what is this Pascal's wager? According to Pascal, there are two decisions that you can make in this life. Number one, it's either you reject God or to accept God. Now, if your decision to reject God, right, but you found out that God exists, then it's a big mistake. And if your decision is to reject God and God doesn't exist, well, you are correct. Or if your decision is to accept God, God exists, then you are correct. And if your decision is to accept God, but God doesn't exist, it's a minor mistake for you. So that's how simple hypothesis testing is. There are actually pitfalls in testing hypothesis. Number one pitfall is what we call the overemphasis on p-values. Second is association does not equal causation. The third pitfall is that the difference resulted from the combined effect of small imbalances in the groups. That's another danger. And another pitfall is that results that are not statistically significant should not be interpreted as evidence of no effect, but rather as no evidence of effect. And the last pitfall is that the fallacy of comparing statistical significance. Now, how about confidence interval? Confidence interval, estimates of a parameter, consists of an interval of numbers along with the probability that the interval contains the unknown parameter. Okay, let me give you the general procedure in hypothesis testing. The first one is to formulate the null hypothesis and the alternative hypothesis. By the way, null hypothesis is represented by HO and alternative hypothesis is represented by H1 or HA. That's the first one. You formulate the null and alternative. Second is that you select appropriate tests. Third is that you choose level of significance. Number four is that you calculate the test statistic. Number five is to determine the probability associated with a statistic. And number six is that determine the critical value of the test statistic. Or compare the level of significance and then determine if the critical value falls in the rejection region. In this case, you have to check the tables. Okay? Or number seven, you reject or do not reject the null hypothesis. And after doing so, you are at the last step, which is that you are going to make the final conclusion or draw the conclusion for that matter. Now, hypothesis testing for independent sample. The independent measures hypothesis test allows the researchers to evaluate the mean difference between two populations using the data from two separate samples. And how about for dependent samples? When you compare two populations, and some examples are, you use this one for comparing two populations. And one way to exemplify this one is this one. Is there a difference in the mean value of residential real estate sold by male agents and female agents in Cavite? Now, comparing to population means, first thing to consider is that no assumptions about the shape of the populations are required. Second, the samples are from independent population. Let me move on to the chi-square. Chi-square statistic. That there are characteristics of the chi-square distribution. Number one, it is not systematic. It is not symmetric, I mean to say. Second, the shape of the chi-square distribution depends upon the degrees of freedom, just like students' t distribution. Number 3, as the number of degrees of freedom increases, the chi-square distribution becomes more symmetric. Number 4, the values are non-negative. That means to say that the values are greater than or equal to 0. Chi-square goodness of fit. A goodness of fit test is an inferential procedure used to determine whether a frequency distribution follows a claimed distribution. Now, chi-square test of independence. Chi-square is used for nominal data placed in a contingency table. And what is this contingency table? A contingency table is a two-way table showing the contingency between two variables, where the variables have been classified into mutually exclusive categories and the cell entries are frequencies. There are 5 types of statistical analysis. 1 is descriptive, 2nd is inferential, 3rd is the differences, 4th is associative, and the 5th one is predictive. I'm going to say descriptive. Let me go back to what descriptive is. If you want to know something about descriptive statistical analysis, you ask this question: what are the characteristics of the respondents? But if your question would be, what are the characteristics of the population, then that falls under inferential. But if your question is this, are 2 or more groups the same or different, that falls under differences. And if it is associative, this may be your possible question. Are 2 or more variables related in a systematic way? Or if it is predictive, can we predict one variable if we know 1 or more other variables? Now, differences between groups when comparing means. First one is the ratio scale dependent variables. Now, when to use the t-test and when to use the z-test. The t-test is used when groups are small. Second, when population standard deviation is unknown. And when to use the z-test. Z-test specifically is used when groups are actually large or the sample size is large enough. Now, we also have to consider the term degrees of freedom. Degrees of freedom is equivalent to n minus k, where n is equal to n1 plus n2, and so on. And k is the number of groups. Now, the number of freedom is, open and close parenthesis, n1 plus n2 minus 2, or in any case that matter. Now, test for means, difference, and paired samples. What is actually a paired sample? When 2 sets of observations relate to the same respondents, that is also paired sample. And when you want to measure a brand, recall before and after an ad campaign, that is also paired sample. Since it is a sample population that is being sampled, the observations are not actually independent. The appropriate test for this one is paired t-test. I'm now on the last of the topics about inferential statistics, and this is what we call the ANOVA. ANOVA stands for analysis of variance. And what are the purposes of using ANOVA? Number 1, extends the test for mean difference between 2 independent samples to multiple samples. Second, employed to analyze the effects of manipulations on a random variable, or it's called the dependent variable. What is a ANOVA test? The null hypothesis tests whether the mean of all the independent samples is equal, or the alternative hypothesis specifies that all the mean are not actually equal. One way ANOVA investigates the following: main effects, or it could be the factor has an across the board effect, example the age or gender. A two-way ANOVA investigates one interaction. Effect of one factor depends on another factor. It's a larger, say for example, larger advertising effects for those with no experience. I think that would be all for the summary for inferential statistics. Thank you for listening.